This is the second video in a series on right triangle trigonometry. And in this video, we are focused on problem solving. If you didn't watch the first video, this might not make a lot of sense to you. I recommend you go back and watch that one first. If you're participating with us today, you're going to want to have access to a calculator. And that calculator needs to be in degree mode. So find the mode button, find the angle option, make sure it's selected on degree and not radian. And the first problem we do here, we're going to need the calculator because it asks us to find the secant of 32 degrees. So secant, I look on my calculator and I see sine, cosine, and tangent, but I don't see a secant button. The way that we get to that is, remember, secant is 1 over cosine. So to get secant 32, just remember, secant of 32 degrees is 1 over the cosine of 32 degrees. And that is something that I can dial up on my calculator. Now let's see how that looks. It's 1 divided by cosine 32. I'm supposed to round this to 4 decimal places, so that's 1.1792. This second problem is similar in that it asks you to find a cotangent. There is no cotangent button. There is only sine, cosine, and tangent. But if you know cotangent is 1 over tangent, then you can solve this problem by going like this. Cotangent 28.5 degrees is 1 over the tangent of 28.5 degrees. And because my calculator does have a tangent button, I can just push this right here, 1 divided by a tangent 28.5. And it comes up to the nearest 4 decimal places, 1.8418. 1.8418. Okay, now we have a problem where there's a triangle. Some information about the triangle is given. Quite a bit of it is missing. Okay, so they call this solving a triangle. Solving a triangle means finding all the missing dimensions. There are 3 angles and 3 side measurements, and we're going to use some trigonometry and some angle addition ideas to find them out. First, let's do the easy one. They tell us angle C is 90 degrees, and they mark it with this little red box here. That means 90. They also tell us angle A up here is 27 degrees. Well, how big is angle B? Okay, in a right triangle, the 2 acute angles have to add up to 90. So this 90 takes half of the 180 degrees we know has to be the total of the 3, and that means that the other 2 have to add up to 90. They're complementary angles. So if A is 27, it turns out you need 63 degrees to get angle B. You might want to check that 27 plus 63 makes 90, or check that all 3 of these add up to 180. All right, now we're going to calculate side CB. Its dimension is called little a. And I think I'm going to go and refer to this angle up here. Angle A, remember, is 27 degrees. See, and I know that B, this side measurement here, is 9. Well, A and B are their legs. And relative to angle A, this is an opposite leg and this is an adjacent leg. And remember, tangent is opposite over adjacent. So the tangent of angle A is dimension A over dimension B. It's opposite over adjacent leg. Now I can put some numbers in here. Tangent of 27 is equal to A over 9. And if you multiply both sides by 9, you come up with 9 times 27. 9 times the tangent of 27. is equal to A. So let's enter that into our calculator now. 9 times tangent 27. You get 4.59 to the nearest hundredth, 4.59. So that's how big A is. Finally, we're going to get C. I think I'll continue to work with angle A up here, which remember is 27 degrees. And C is the hypotenuse. Now, because they gave me dimension B, and because I had to round to get A, I don't think I want to use A to help me find C. I'm going to use B. And the way I'm going to do it is, remember, relative to angle A, B is the adjacent leg, and C, no matter where you're looking from, is a hypotenuse. Adjacent over hypotenuse is cosine. So I have cosine of angle A is dimension B over dimension C. It's adjacent over hypotenuse. And we'll put some numbers in here now. The cosine of 27 degrees is dimension B over the last missing dimension, C. Now, when I have a variable down here equal to some trig value, the best way I know to finish this problem is just to trade places with these two. And then you get C equals 9 over cosine 27, which is pretty easy to enter into the calculator. 9 over cosine 27 is 10.10 to the nearest hundredth. So C is going to be 10.10. And this problem comes right off of an online assignment that my students are about to do. It's from I think it's called the Big Idea textbook. There's some pretty good problems in there, I guess. All right, here's another one of these solve for the whole triangle problems. It'll be the last one we do. But again, the easiest thing to do is figure out the missing angle. When two angles are given, you get the 90-degree angle. Then you have these two acute angles. The two acute angles have to themselves add up to 90. They have to be complementary. So what you'll need here is another 18 degrees, because 18 plus 72 makes 90. Now C is given as 12.8. That's how long the hypotenuse is. And we can pick either A or B to start with. I guess it doesn't really matter. I'm going to go with A. And I'm going to use angle A up here. Okay. So relative to angle A, this little a is the opposite side. C, of course, is the hypotenuse. Opposite over hypotenuse is sine. So I have sine of A is equal to A over C. Now, why did I pick C? Why didn't I do something with A and B? Well, because I don't know either one of those. So you have to use a number that you know. So putting in some values here, the sine of A is sine of 18. And then little a over C is A over 12.8. Multiply both sides by 12.8, and you will know what A is. So 12.8 times the sine of 18 degrees is the value of dimension A. So 12.8 times the sine of 18 degrees is to the nearest hundredth, that's 3.96. So little a is 3.96 approximately. And then to get B, I think I'll go ahead and use angle A, and B is the dimension of the adjacent leg. C, of course, is the hypotenuse. Adjacent over hypotenuse is cosine. So cosine of A is dimension B over dimension C. So cosine of 18 degrees is the unknown B over the given C. Multiply both sides by 12.8, and you'll be done. So 12.8 times cosine of 18 will return a value of B. (12.8) times the cosine of 18. And you get to the nearest hundredth, 12.17 for B. Okay, so those were two problems where you had to solve a triangle. In other words, find all the missing information. Next, and this also comes out of our online assignment, there's a application to determining the width of a river that you're not actually going to cross. And the way you're going to do this, you can read through this on your own, but I'll just summarize what happened. Somebody noticed a boulder on the opposite bank, and excuse me, from a point directly across from the boulder, they drove a stake in the ground, then they walked 100 meters, and then somehow measured the angle with the river bank and the line of sight to the boulder. They got 79 degrees. Well, if you could do all that, if you had the right equipment, you could then figure out how wide the river is. How? Well, that's an acute angle. This is a right triangle. Relative to this angle here, W is the opposite leg and 100 is the adjacent leg. Opposite over adjacent is the tangent of that angle. So you set this up quite easily. It's tangent of 79 equals W over 100. Multiply both sides by 100 to find that 100 times the tangent of 79 equals W. So 100 times the tangent of 79 degrees. And we come up with 514 point, well, to the nearest meter, it's 514 meters. But that's pretty close to a half meter, isn't it? So 514 meters is the answer. Now, this problem is a little confusing. They label one of these acute angles as theta, and then they tell you that the other one is 90 minus theta. Well, that turned out to be right. For example, if this is 20 degrees, this is 70 degrees. 90 minus 20 is 70. Because remember, these two have to add up to 90. They are complementary angles. So that the total with these two and then this 90 equals 180. We are to write an expression for sine theta. Sine is opposite leg over hypotenuse. So that's y over h. And then we're supposed to turn around and find the cosine of the other acute angle, 90 minus theta. Well, cosine is adjacent over hypotenuse, so that is also y over h. No, your eyes are not playing tricks on you. These are supposed to come out the same. If the sine has some value, then the cosine of the complementary angle has the same value. In fact, the co in cosine, the co is, that means complementary. And let's try tangent of theta. Okay, so that's opposite over adjacent leg. So that's y over x. And then what about the cotangent of 90 minus theta? Well, cotangent is adjacent over opposite, so you get y over x again. And no, once again, that's not an accident. They're supposed to come out the same. Because the cotangent of the complement of an angle has to equal to the tangent of that angle. Okay. This problem is hard. I put a lot of space down here because I think there's some rather involved algebra compared to anything else we've seen today. I'll just quickly give you the background so that you don't have to invest a lot of time reading it. There is a building, and you are some unspecified distance away from that building, and you measure from ground level a line of sight to the top of the building. They call this the angle of elevation, and it's 30 degrees. 30 degrees. And then you walk 40 meters closer to the building, like this. So you walk a distance of 40, and you measure that angle of elevation again, and it might not look like 60 degrees, but this time the angle of elevation is 60. In other words, you have to look up at a steeper angle. Now, they don't tell you how far you are from the building in the beginning. They don't tell you how far you are from the building after you've walked 40 meters, so we'll just call that x. And our goal is to figure out how tall the building is, and that's h. Well, there are a couple of equations I can write here involving tangents. Number one, the easy one is tangent of 60 degrees is the opposite leg over the adjacent leg. And that's, that's h over x. Okay? H over x. And then 30 degrees down here has a tangent that looks like this. It's h over 40 plus x. It's opposite over the adjacent, and the adjacent is what you get when you combine 40 and x. So that's h over 40 plus x. Now what I'm going to do is solve both these equations for h. So when I solve this one for h, I multiply both sides by x. I get x tangent 60 degrees equals h. And this one, if I multiply both sides by 40 plus x, I get 40 plus x times tangent 30 equals h. Why did I do that? Well, because now I have two expressions equal to h. If this is equal to h, and if this is also equal to h, then these two expressions are equal to one another. So either by transitive property or substitution, whatever you like to call it, I can say that these are equal. Now I'm going to write that equation. X times tan 60 is equal to this. And I'm going to distribute tangent 30 through here. I'll multiply times 40, I'll multiply times x, so I'm going to get 40 times tangent 30 plus x times tangent 30. Now, on this side of the equation, there's two terms. One of them has x. I think I'd like to have that term over here. So I'll subtract this from both sides. Subtract it here and subtract it over here. And what the result is, well, I'll just write it down here to be thorough. And then you'll see what that looks like. On the right, these cancel. So there's nothing more on the right than 40 times tangent 30. And then on the left, I have these two expressions. Go ahead and write those down. So that's x tan 60 minus x tangent 30. And I move those together with intent because they both have x. So you can factor x out. And when you do that, you have tan 60 minus tan 30. And now we're getting somewhere, aren't we? And then on the right, I still have 40 times tangent 30. And you know what I'm going to do next, don't you? Yep, I'm going to divide by that. It's 40 times tangent 30. And then when you divide by these two terms, you're going to want to put them in parentheses so that you are certain that you are dividing by both of them and not just the tangent 60. So I open a parenthesis here. Then I write tan 60 minus tangent 30. I close the tangent and I close the divisor and hit go. And x comes out to, look at that, it's a nice whole number. X is 20. Well, then how do you figure out what h is? We'll go back up here. Remember, h is x times tangent 60, and we now know that x is 20. So to get h, I go x times tan 60, and that's 20 times tangent 60. And we're about to learn how tall this building is. And 20 times tangent 60 is 34.6 meters tall. And they don't tell us anything about how to round it, so I'm just going to round it to the nearest tenth. 34.6 meters is the height of the building. Okay, one more problem. And this problem involves some geometry ideas. They have this circle where they tell you it has a unit radius. They went ahead and marked these as equal. That was kind of nice of them. You should know that a radius is equal to a radius within a circle. This is also a radius. So all three of these are 1s by assumption. But this is 1 just because of the placement of this point. It doesn't have to equal 1 here. They're just telling you, we'll put that point so that this side is also 1. Now, do we know any angles in here? Certainly. we can figure out what theta is pretty quickly. But first of all, if this is an equilateral triangle, you probably know it's also equiangular. So these three angles are all equal. They have to add up to 180. 180 divided by 3 is 60. So I have a 60 and a 60 and a 60. And these two are supplementary, aren't they? So that means that has to be 120. And these being equal make this an isosceles triangle, which makes these two angles equal. So 180 minus 120 is 60, divided by 2 is 30. So you get 30 here, and you get 30 over here. Now they want us to write down the 6 trig values for this. I suppose we could. One way you could do it is you could say, well, that's the hypotenuse of a right triangle, because 30 and 60 is 90. So that's a right angle. And this is the hypotenuse. This is the one of the legs. I guess it's the shorter leg. How could you figure out this longer leg here? Well, it's bigger than 1, but it's smaller than 2. And so what you could do is you could put x on it, and then you could use the Pythagorean theorem, where you go this leg squared plus this leg squared equals this hypotenuse squared. I think I'll do that now. X squared plus 1 squared equals 2 squared. So x squared plus 1 equals 4. Subtract 1 from both sides, you get x squared equals 3. The positive square root is the one we're after, and it's square root 3. I'm not surprised that it's square root 3, and you probably aren't either, because this is one of those special 30, 60, 90 triangles you were supposed to have studied in geometry. But now that we know all three sides, the hypotenuse 2, the shorter leg 1, the longer leg root 3, we can go ahead and figure out the sine of theta, the cosecant of theta. We can get the cosine of theta, and we can get the secant of theta. We can get the tangent of theta, and we can get the cotangent of theta. And some of these we'll probably end up dividing by square root of 3, so we'll talk about how to simplify those in short order. Well, let's see. Where was theta? It was back here. Sine would be opposite leg divided by hypotenuse. So that's 1/2. And that means that the cosecant is 2 over 1. Or just 2. Cosine of theta would be the adjacent leg divided by the hypotenuse. So that's root 3 over 2. The secant is 2 over the square root of 3. Don't let anybody tell you that that's wrong. But they also might say, hey, you got to simplify that. You got to multiply up here by root 3, multiply down here by root 3 to get a simplified 2 root 3 over 3 answer for that secant. Okay? And then tangent theta would be, for this theta here, it would be the opposite leg over the adjacent leg. That's 1 over root 3. But again, now you're dividing by root 3, so you multiply it by root 3 here and root 3 there, and you end up with root 3 over 3. So that's the tangent. And finally, the cotangent would be where you take this original tangent and you flip it over. That's root 3 over 1, or just square root 3. Well, we did all 6 trig functions. We used a little bit of geometry. I think that's it for today. Hope you enjoyed this. Maybe you learned something. My name's Eric. Have a good day.